Okay, Faraday's law. So, Faraday's first law of electrolysis state that quantity of substance formed at an electrode, cathode or maybe anode, is directly proportional to the quantity of electrical charge supply. So, quantity of substance formed at cathode or maybe anode directly proportional to the quantity of charge supply. So quantity of charge, the symbol is Q. Okay, and then the unit is coulomb. So how to calculate quantity of charge supply using this formula? Q equals to IT. I is current in unit ampere. T is time in unit second. Okay. Okay, Faraday's first law of electrolysis. So 1 mole of electron, it will carry 96,500 coulomb. So 96500 coulomb equivalent with 1 Faraday. So when one electron move, it will carry 96,500 coulomb of electric charge. Okay, so for Faraday, the requirement is half equation, whether it's cathode or anode. For nurse, you need to have overall equation for expression of Q. But for Faraday, I would like to know half equation at cathode or anode. Okay, example 1, an aqueous solution of copper sulfate is electrolyzed using a current of 0.15 ampere for 5 hours. Calculate the mass of copper deposited at cathode. You want to find mass of copper deposited. So first you calculate electric charge using this formula. Q equals to IT. So I is 0.15 ampere. So time must be in seconds. So 5 hours convert to second. So you will get 2,700 coulomb. Okay. So at cathode, so now we need to have half equation at cathode. So in this case, at cathode, cation will attract to cathode. So copper 2 plus will have competition with water. Okay, so copper 2 plus is cation from less reactive metal. So copper 2 plus will be chosen to undergo reduction. Okay, not water. Okay, so copper 2 plus equals receive 2 electron producing copper solid. So the question asks you how much, what is the mass of copper solid deposited at cathode. Okay, so theoretically, if cathode receive 2 electron, which is receive 2 Faraday, 2 times this value, okay, so it will produce 1 mole of copper. Okay, theoretically, at cathode, if it receive 2 mole of electron, it will produce 1 mole of copper. But then in this experiment, we don't have 2 Faraday. We only supply 2,700. So 2,700 coulomb. So equivalent with, so mole must be 4 decimal places. So if I round off, it will be 0.014 mole copper. So this is actually stoichiometry. Okay, this is the stoichiometry. So on the left hand side must be coulomb and coulomb. Right hand side is mole and mole. Okay, so whatever that you want to find, it must be on your right hand side. Okay, you cannot mix up. This is coulomb and then this is mole, but here is mole and then you want to find coulomb. It cannot be like this. Left hand must be coulomb, right hand must be mole. Okay, and then whatever that you want to find must be on your right hand side. Okay, so you already calculate the mole. So if you want to find the mass, so mole times with molar mass of copper. So given here 63.5 gram per mole. Okay, so the mass deposited is 0.889 gram. Electrolysis of molten calcium bromide using carbon electrodes carry out calcium bromide. If an electric current of 5 ampere was passed through the molten salt for an hour, calculate the quantity of electric in Faraday. So the first question. Second question, mass. So there are two questions here. So first you need to calculate the quantity in Faraday. And then the second question, calculate the mass of calcium produced. So molten means no water and then the phase is liquid. Okay, first you need to calculate Q equals to IT. You need to calculate electric charge. So given the current here is 5 ampere. And then for an hour. So 1 hour you have 60 minutes, 60 seconds. So you need to convert to second. So you get 18,000 coulomb. Okay, so first question, calculate the quantity of electric in Faraday. So 1 Faraday is equivalent to 69500 coulomb. So here you only have 18,000. So you want to find Faraday. Faraday must be on your right hand side. So 96500 coulomb equivalent with 1 Faraday. So you only have 18,000 coulomb. So equivalent with 0.11865 Faraday. So this is the amount of electric in Faraday. Okay, so next find the mass of calcium produced. So calcium is positive charge. So calcium attracted at cathode. So at cathode, okay, cathode attract positive charge, attract cation. So calcium in form of liquid, because this is molten, receive 2 electron, so it will produce calcium in form of liquid, or you can write down solid. Okay, so if you cool down, so it will become solid. So at high temperature, it will become still in form of liquid, still in form of molten. Okay, so according to the half equation, if cathode receive 2 electron, so it will produce 1 mole of calcium. Okay, cathode receive 2 electron, so 2 electron equivalent with 2 Faraday, equivalent with 2 times 69500 coulomb, equivalent with 1 mole of calcium produced. So in this experiment, we supply 18,000 coulomb. So this is the amount of mole produced. So mole must be at least 4 decimal places or more than that. Okay, so this is the amount of mole calcium produced. And then when you have mole, you can calculate mass. Okay, mole times with the molar mass. So molar mass is given in the question. Okay, so this is the mass of calcium produced at cathode. Again, theoretically, when you supply 2 mole of electron, so when you supply 2 mole of electron, 1 mole of calcium will produce. Okay, 2 Faraday, 1 mole. But then in this experiment, we only supply 18,000. So this is the mole produced. Okay, in this experiment, so this is the mass. Using platinum electrodes. During the electrolysis, a current of 2.5 ampere pass through a solution for 2 hours. So write the equation involved at anode and cathode. So this is aqueous copper sulfate. So at cathode, it will attract positive charge cation. So copper 2 plus will go to cathode and then water. So which one will be chosen to undergo reduction? So copper 2 plus. So copper 2 plus receive 2 electron. Okay, producing copper solid, while at anode, okay, an ion will go to anode, sulfate and also water. So which one will be chosen to undergo oxidation? So water. So water, okay, remove electron. Anything remove electron will produce positive charge. And then remember, acidic. So oxygen gas will produce. So if you balance the equation, okay. So this is the balance equation at anode. So calculate the amount of oxygen gas collected in mole. Amount of oxygen gas. Okay, collected in mole. Okay, so if you look at half equation at cathode, there is no oxygen gas produced. If you look at half equation at anode, so oxygen gas is produced. So we want to refer half equation at anode. Okay, so because the question asks you to find oxygen gas at collected. So oxygen gas is collected at anode. So as usual, we calculate Q first. So given in the question, 2.5 ampere and then for 2 hours. Okay. And then as usual, we calculate Q equals to IT. So 2.5 ampere. So 2 hours convert to second. Okay, 18,000 coulomb. So according to the half equation at anode, so if anode remove 4 electrons, so 4 electron, it will produce 1 mole of oxygen gas. So 4 electron equivalent to 4 Faraday, equivalent to 4 times 69500 coulomb, equivalent to 1 mole of oxygen gas. So in this experiment, we only supply 18,000 coulomb. So it will produce 0.0466 mole of oxygen. So that is the final answer. So mole of oxygen produced is 0.0466 mole. Okay, because the question only asks to find mole of oxygen collected. So oxygen is collected at anode. So we only refer half equation at anode. Okay. Okay, last example. A current of 2 ampere passed through for 30 minutes through a cell consisting of graphite electrodes and a solution of potassium sulfate at 25 degrees Celsius. The question asks you to calculate volume of oxygen gas evolved at anode. Okay, so we calculate Q first. Q equals to IT. So 2 times V60 times convert to second. So you will get 3,600 coulomb. Okay. So we want to find volume of oxygen gas at anode. So at anode. Okay. So water will be oxidized because at anode. Okay, anode will attract negative charge. So in this case, your negative charge is sulfate and also water. So water will be chosen to undergo oxidation because ozo and ion. You cannot choose ozo and ion. So water remove electron producing H plus. Okay, urin berakali. So oxygen gas. So if you balance this one, so theoretically, 4 electron for Faraday, it will produce 1 mole of oxygen gas. Okay. Okay, theoretically, 4 mole of electron equivalent with 4 Faraday, so equivalent with this value, it will produce 1 mole of oxygen gas. So anode, it will release 4 mole of electrons, so it will produce 1 mole of oxygen gas. But in this experiment, you only supply 3,600 coulomb. So 3,600 coulomb, so it will produce 9.3264 times 10 to the power of negative 3 mole oxygen. Okay, so the question asks you to find volume. So if you want to calculate volume, you need to know whether this one is at STP or RTP. Okay, STP means condition at 0 degrees Celsius, 1 atm. RTP condition at 25 degrees Celsius, 1 atm. So if we read the question again, the question occurs at 25 degrees Celsius, 1 atm. So it means that you want to calculate volume at RTP. So at RTP, molar volume is 24 liter per mole. STP, molar volume is 22.4 liter per mole. So in this case, it is at RTP because experiment occur at 25 degrees Celsius. So volume of oxygen gas at RTP is equal to number of mole times with 24. So it produces 0.224 liter oxygen gas. Okay, so you need to remember this one. Okay, STP 0 degrees Celsius, RTP 25 degrees Celsius. So this value 22.4 and 24 is given in your exam. Okay, for this question, if you look at this question, so this question also give you half equation. Okay, for water. Okay, you just ignore this value. This value only help you actually to write the half equation at anode. Okay, so this half equation only to help you to check whether your half equation is correct or not. But then this one is anode. This one is value of potential. Potential is being calculated when half cell attract electron. It's like a reduction. So this is water being reduced. But then in this question, water is being oxidized. Okay, so don't confuse with the half equation given. You just write your own. Okay, you just write your own. Okay.